Welcome to the Math School by IFRA. In this video, we are going to discuss numerical method for describing data. Data can be described numerically by various statistics or statistical measures. These statistical measures are often grouped in three categories: measures of central tendency, measures of position, and measures of dispersion. Measures of central tendency. Measures of central tendency indicate the center of the data along the number line and are usually reported as values that represent the data. There are three common measures of central tendency: the arithmetic mean, usually called the average or simply the mean. Number 2, the median. Number 3, the mode. To calculate the mean of n numbers, take the sum of the n numbers and divide it by n. For example, for the 5 numbers 6, 4, 7, 10 and 4, the mean is 6 plus 4 plus 7 plus 10 plus 4 over 5 is equal to 31 over 5, that is 6.2. When several values are repeated in a list, it is helpful to think of the mean of the numbers as a weighted mean of only those values in the list that are different. Consider the following list of 16 numbers: 2, 4, 4, 5, 7, 7, 7, 7, 7, 7, 8, 8, 9, 9, 9, 9. There are only 6 different values in the list: 2, 4, 5, 7, 8 and 9. The mean of the numbers in the list can be computed as: there is only one 2, so the weight for 2 is 1. There are 2 4s, so 2 times 4. There is only one 5, so 1 times 5. There are 6 7s, so 6 times 7. There are 2 8s, so 2 times 8. There are 4 9s, so 4 times 9. Over 1 plus 2 plus 1 plus 6 plus 2 plus 4 divided by the weights is equal to 109 over 16 is equal to 6.8125 is our answer. The number of times a value appears in the list or the frequency is called the weight of that value. So the mean of the 16 numbers is the weighted mean of the values 2, 4, 5, 7, 8 and 9, where the respective weights are 1, 2, 1, 6, 2 and 4. Note that the sum of the weights is the number of numbers in the list, which is 16. Again, the sum of the weights is the number of numbers in the list, which is 16. The mean can be affected by just a few values that lie far above or below the rest of the data, because these values contribute directly to the sum of the data and therefore to the mean. By contrast, the median is a measure of central tendency that is fairly unaffected by unusually high or low values relative to the rest of the data. To calculate the median of n numbers, first order the numbers from least to greatest. Again, to calculate the median of n numbers, first order the numbers from least to greatest. If n is odd, then the median is the middle number in the ordered list of numbers. If n is even, then there are middle numbers, and the median is the average of these two numbers. Let's have a look at another example. The 5 numbers 6, 4, 7, 10, 4 listed in the increasing order are 4, 4, 6, 7 and 10. They are arranged in the ascending order. So the median is 6, the middle number. There are odd number of numbers and the median is the middle number, which is 6. The middle number is 6. Note that the number 10 in the list is replaced by the number 24. The mean. Now, if the number 10 in the list is replaced by the number 24, the mean increases from 6.2 to 4 plus 4 plus 6 plus 7 plus 24 over 5. We have replaced 10 by 24. It's 45 over 5, that is 9. So the mean has been changed from 6.2 to 9. But the median remains equal, which is 6. This example shows how the median is relatively unaffected by unusually large value. The median, as the middle value of an ordered list of numbers, divides a list into roughly 2 equal parts. However, if the median is equal to one of the data values and if it is repeated in the list, then the number of data above and below the median may be rather different. For example, the median of the 16 numbers 2, 4, 4, 5, 7, 7, 7, 7, 7, 7, 7, 8, 8, 9, 9, 9, 9 is 7. But 4 of the data are less than 7 and 6 of the data are greater than 7. The mode of the list of numbers is the number that occurs most frequently in the list. Again, The mod of the list of numbers is the number that occurs most frequently in the list. Let's have a look at an example. The mod of 6 numbers in the list 1, 3, 6, 4, 3, 5 is 3. A list of numbers may have more than one mod. The mod of the 6 numbers in the list 1, 3, 6, 4, 3, 5 is 3 because 3 has been repeated twice. So a list of numbers may have more than one mod. For example, the list of 11 numbers 1, 2, 3, 3, 3, 5, 7, 10, 10, 10, 20 has two mods, 3 and 10.